Hi, good afternoon, everyone. It's Maria Laskaris, Dean of Admissions and Financial Aid at Dartmouth College, and welcome to, I think, our fourth installment of Conversations with Admissions. This afternoon, our topic is engineering at Dartmouth and what it's like to study engineering at Dartmouth College, why you should think about Dartmouth College if you're interested in pursuing engineering. And I'm really pleased this afternoon to have joining me for the chat Joe Helble, who's the Dean of the Thayer School of Engineering at Dartmouth. I'm going to ask Joe to introduce himself and tell us a little bit about his background and also the work of the Thayer School of Engineering, and then we'll get to your questions. So while we're talking, please feel free to post your questions on the website and we will get to as many of them as we can. So Joe, welcome, and if you could tell us a little bit about yourself and about engineering at Dartmouth, that would be great.
Thanks very much, Maria. So I'm Joe Helble, as Maria indicated. I'm the Dean of Engineering at the Thayer School here at Dartmouth, and I've been here as the Dean of Engineering for 5 years. I was trained very traditionally as a chemical engineer, and one of the things I will stress in talking a little bit about the Thayer School, and I think you will have noticed if you've taken a look at Dartmouth and looked at our website, is that engineering here, in fact, is not taught in a very traditional, rigid, disciplinary, boundary-structured way. It's interdisciplinary, collaborative, hands-on, and really, I think, reflects what the 21st century needs from broadly and liberally educated engineering professionals. I am a chemical engineer by training. I have spent time in the private sector. I spent time working in the government, including on environmental policy in the Senate, and I've spent time as a professor and teacher working on issues of environmental concern, principally air pollution. Being here at Dartmouth has been a wonderful experience for me because I think it really does combine the best of liberal arts breadth and also the ability to dive deeply into particular areas of engineering that are relevant for the 21st century. We have at the Thayer School a very hands-on, design-oriented curriculum. We have a very innovative and entrepreneurial student body. I like to point out to people that about 10% of our undergraduates wind up filing for patent protection on something they do by the time they graduate. So it's really an exciting and stimulating and different place to study engineering in a very interdisciplinary and team-oriented way.
Great. That leads actually into a question that Alex Rowe posted. He says, I keep hearing how interdisciplinary the engineering program is at Dartmouth. Could you actually elaborate on what that means for students? I think that's a great question.
Sure, that is a great question, and interdisciplinarity, I think, has almost become trendy or a buzzword, but we really are interdisciplinary by design. If you look at most engineering schools in this country, you'll see that they have very traditional mechanical engineering and chemical engineering and civil engineering and so on departments. We don't. We teach engineering in a single integrated school. You can pursue study in areas of mechanical or biochemical or electrical engineering and so on, but we really teach it in an integrated, project-oriented, systems-based way. So what does that really mean? It means if you're interested in studying mechanical engineering, even though you will focus on mechanical engineering subjects, you will also build electronic circuits, learn computer coding, learn something about fluid flow. You really look at engineering systems broadly. The same is true for the other disciplines. And I think if you think about the problems that are facing engineers in areas like healthcare or the environment or energy, things that we focus on here at the Thayer School, no single discipline really gives you the tools to study those in depth, but combining the best elements from different disciplines really does. So that's the way we approach engineering.
One of the things that I'm seeing pop up a lot on the chat, so I want to just address this question, just a logistical question. Since the question is, do you apply to Dartmouth or do you apply to the Thayer School of Engineering if you want to be an engineering student at Dartmouth? And as an undergraduate, you apply to the college. You apply to Dartmouth College, and engineering is a major. So students typically declare their major at the end of their sophomore year. So you have a couple of years before you have to formally declare yourself as an engineering major, but just want to let folks know that you would apply just to Dartmouth. We don't require that you declare a major at the point of admission, but really at the end of your sophomore year. However, I think it's fair to say that students who are thinking about engineering probably have to do some work early on in their Dartmouth career to prepare in terms of prerequisite courses. So it might be really helpful to talk a little bit about what you might do your first year or your second year.
Right, they do. Although Dartmouth is a liberal arts institution and there's of course a lot of flexibility in major selection, students who are interested in engineering will tend to take a higher concentration of math and science courses during their freshman year. So chemistry, physics, sometimes biology, and certainly several math courses. And of course the specifics vary depending upon whether a student enters with AP credit, depending upon the student's specific preparation. But students here don't declare majors until the end of their sophomore year. And while many of our students do know they want to be engineering majors coming in, we have many students every year who don't decide until they've taken a first engineering class, often one that has a design project associated with it, and find they've gotten really excited by the creative aspects of engineering. And so there are prerequisites that are important to take that are absolutely critical for the engineering curriculum. Most of our students do start working on that freshman year, but Dartmouth's curriculum gives you a fair amount of flexibility.
Right, and going along with that, if you think about the courses you'll take at Dartmouth, we have a couple questions. One from Ashkay asks if you can pursue a foreign language while majoring at Dartmouth. So can you essentially double major in a foreign language and engineering? And the answer is yes, and the answer is that we do have a one-year language requirement for all of our students, but certainly you have occasions where students, more than one occasion, right, will major in more than one subject, engineering and something else. Maybe you could talk about how students arrange those double majors.
Right. Yeah, very carefully
Yeah.
is how they arrange the double majors. But Dartmouth students are incredibly creative in terms of identifying different elements of the curriculum that work well for them. So we have students who combine engineering study with economics, students who combine engineering study with study in studio art, and students who combine engineering with study in a foreign language. And there are faculty advisors to help guide you along the way, and it's very easy to get connected with a faculty member in engineering and someone in one of the language departments to find ways to make that work. Engineering students pursue foreign study just like students in other majors, and in fact for students who are interested, we have an engineering exchange program with the university in Bangkok, Thailand, where engineering students can take engineering classes to meet their engineering major requirements in Thailand.
Right. I think that's also a great segue, perhaps to talk a little bit about internship opportunities. We've got a couple questions here from CM McKay and some others about internships. And Dartmouth students, because of the flexibility of our curriculum, the Dartmouth plan, the calendar system, have opportunities to do some really interesting things in terms of internships while they're not taking classes. And we certainly believe that the education here is much broader than just what you get in the classroom. So what kinds of internships do engineering students take advantage of, and how easy is it to do that as an engineer?
Right. There's a wide range of internships that engineering students will pursue. Some of them will do an internship on campus where they will work in a faculty member's laboratory, and some of them who have research interests can start doing that from the time that they're freshmen. Others want to pursue a position in industry to get an industrial experience as part of their education, and we actually have a career services office within the engineering school that has an internship career fair every January or February and helps our students make these matches and makes these placements. And as you had indicated, Maria, the flexibility of Dartmouth's curriculum, particularly the Dartmouth plan and the flexible schedule, gives students the opportunity to take 2 off terms back to back where they can pursue a 6-month internship or be doing an internship at a time when students at other schools are in session, and that gives you a tremendous amount of flexibility, I think in finding a good opportunity.
Yep.
For students who want them, the opportunities are there.
Great. We've got some more nuts and bolts questions, so I'm going to jump around a little bit and do some of the nuts and bolts because I think these are really important questions. One is, what is the difference between the AB degree in engineering and the BE? And I think this is something that's really worth maybe spending a little time so students understand what's possible at Dartmouth.
Right. It's a really good question, and there aren't many universities or colleges that offer the AB and the BE. Some will give you a choice either or. At Dartmouth, it's very easy and in fact common for engineering majors to get both. So the AB, the Bachelor of Arts degree, is a liberal arts degree where you would be pursuing a liberal arts curriculum majoring in engineering. That's great preparation for going to law school or medical school or going to work in the business environment. It's also, in some cases, preparation for a very broad-based engineering career. but most of our students, about 75% of them, get the Bachelor of Arts, the liberal arts degree, and the BE, the Bachelor of Engineering degree. At many universities, it's called a BS, a Bachelor of Science, and that is the much deeper science and math-focused component of the engineering education. By combining both, we think students get the best of both worlds. You get the breadth of the liberal arts education and the depth in a particular engineering area, and that leaves our graduates incredibly well prepared to tackle challenging positions in technology and in management.
We've got some students who are asking questions as well, I think about that depth. So they're wondering about, do we have opportunities for biomedical engineering as
Yes.
one? The other is computer engineering.
Yes.
And so anything you want to say about sort of what students do in terms of specializing and
Right.
pursuing a particular interest in
Right.
depth?
Right. The Bachelor of Arts degree, although students can begin to concentrate in one of the different areas like mechanical or computer or electrical and so on, it really is, as we discussed, a liberal arts degree. In the Bachelor of Engineering degree, students will specialize, and we expect you to pick one of these areas to concentrate in. So it will be mechanical, it will be electrical, it will be biochemical, it will be biomedical. These are computer engineering as well, a broad range of engineering areas, what you would see as disciplines or departments at other schools. Students who complete the BE in any of these fields are very well prepared for jobs in those areas, very well prepared for admission to master's and PhD programs at leading universities in these areas. So our students do go to top PhD programs in chemical, biochemical, mechanical, and so on.
Yeah.
So again, if after you pursue both degrees, you've got the depth as well as the breadth.
Excellent. And we have a question from Julie Ann, and I think the answer to this is yes, but I just want to check since I've got the expert here. Can students who enter Dartmouth with AP credits earn their AB and BE in 4 years as opposed to 5?
Absolutely.
And I do think the answer is yes to that, right?
It's absolutely, it's a good question, Julianne, and about a quarter of our students, a quarter of those who get both degrees do get both in 4 years.
Okay.
So it's very possible.
And I know that engineering is one of our largest majors on campus, and we have a question here of how many undergraduates major in engineering in every year.
Right. And the great thing about Dartmouth is being one of the largest majors means it's still a relatively small major. We graduate between 60 and 80 students with a Bachelor of Arts degree in engineering every year, and this is in an engineering program that has 47 members of the faculty. And so even if a surge in interest in engineering led us to have 100 majors, there would still be a 2-to-1 student-to-faculty ratio in the graduating class.
Okay, great. And I think we're going to take one more question on this topic and then do something a little bit different. But we've got a very patient participant who's asking, what's the difference between computer engineering and computer science?
Well, the short answer is hardware, software. But here at Dartmouth, there really is a lot of interaction between the two, and students who major in computer engineering end up taking a lot of computer science courses. Those students who major in computer science wind up taking a lot of computer engineering courses, and the faculty who work in the engineering school in the computer engineering area actually work significantly on not just hardware but on networked communications, coding for robotics, things like this. And so there really is at Dartmouth a very strong interaction between computer science and computer engineering faculty. And so I wouldn't advise students in general to go one way or the other without knowing more about their interests. I think there's a lot of flexibility. So a little more hardware on the engineering side, a little more software on the science side, but it's a very, very fluid boundary.
Great, thank you. I hope that answered the question, and thanks for your patience while we were trying to get to all these questions. There are a couple people who are asking questions about testing, and I thought maybe I'd just tackle that. Some of the admissions nuts and bolts. Students wondering about SAT math scores required or SAT subject tests required if you're thinking about majoring in engineering, or if how do we use the writing scores on the SAT or the ACT essay, particularly if you're thinking your strengths are more math and science. So I thought I could just tackle that for a little bit, just so we get some of the nuts and bolts out of the way. Students applying to Dartmouth, remember you're applying to the college, you're not applying to the Thayer School of Engineering as an undergraduate, so you're applying to Dartmouth College. We have a holistic review process. Through that process, we take a look at lots of information. Most of you are probably in the throes of completing an application right now, so you're aware of all the requirements for admission to Dartmouth and other schools you might be looking at. So your own essays, your personal statements, your transcripts, your secondary school report, a guidance counselor letter, standardized testing, SAT 1 or ACT, as well as any 2 of your SAT 2 subject tests. And because you're applying to Dartmouth College, we don't specify that you need to have SAT 2s in particular areas, but we really leave it up to you to present to us what you think are your best scores and your strengths. We also, of course, have letters of recommendation, the peer evaluation, an optional alumni interview, extracurricular activities. So we have lots of data and lots of perspectives on you as a person, as an applicant. We pull all that together and review you as a whole person and make decisions about whether or not to admit you to join the Dartmouth community. So your specific SAT math scores or ACT essay scores, they don't really have any bearing on whether or not you choose to be an engineering major. Once you've been admitted to Dartmouth, you can choose to major in any one of the 34 or so academic departments and 10 to 15 interdisciplinary programs, regardless of your testing. Once you're at Dartmouth, you really choose the subjects you're interested in as potential majors. So hopefully that helps folks understand how testing is used in the admissions process and a holistic review process. And again, you're applying to Dartmouth College and not to the Thayer School of Engineering as an undergraduate. So that hopefully answers some of those questions. We've had a couple of interesting questions that I think would be great, Joe, if we could get your perspective. Dartmouth is really very proud of the fact that we have a real commitment to teaching, as well as a strong commitment to research. And at the undergraduate college, we take great pride in the fact that our faculty are here because they love to be in the classroom and love to work with students, and also they have very active research lives on their own. So we've got a couple of questions that are wondering about, are there faculty members specifically in engineering who are doing research? What are some of the research projects that faculty are working on? And then how do undergraduates participate and assist faculty in their research as well as doing their own research?
Right. Yeah, those are all good questions. And student research is something that really is an important component of the educational experience here at the Thayer School. It's not required, but the opportunities abound and many students take advantage of them. We have a couple of areas, interdisciplinary areas, where we have a particularly broad range of activity, and one is in the energy and sustainability area. The other's in an area we call engineering and medicine, or it's really another way of thinking about it is the role that engineering broadly is playing and needs to play in the development of healthcare in the 21st century, whether it's new pharmaceuticals or advanced imaging or biomechanics and implant studies or even systems engineering applied to healthcare delivery. How do students get involved in research? It is a very open and friendly faculty here. You knock on someone's door, which is more likely than not open, and walk in and introduce yourself or catch them after a class and talk about your interests. Students from the freshman year on are very welcome in research laboratories here. We have collaborative projects with the medical school, collaborative projects with faculty in arts and sciences as well. There's just a huge range of opportunities for students. Specific projects, we have people who are working on soft tissue imaging, new methods of detecting cancer. We have people who are working on energy efficient electronics and efficient devices. We have people working on cellulosic ethanol development and manufacture. People working on new ways to manufacture pharmaceuticals to measure therapeutic proteins and drugs. Many of these faculty members are entrepreneurs. Companies have been started to commercialize things that have come out of their laboratories, in some cases with undergraduates involved in them. So there's just tremendous opportunity.
I think that's probably, for me, kind of one of the most exciting things about being on campus and getting to know students and seeing what they do with engineering, how they connect that to other interests that they have. And I think, for me, a really great example is this thing we call the Big Green Bus, which started out as a project that a group of students, I believe they wanted to just travel the country to play in ultimate Frisbee tournaments, but they retrofitted a school bus to run on vegetable oil, right? So maybe if you could talk a little bit about that project, because I think that's a really great example of how students connect their academic interests to their extracurricular activities and their passions, and they pull it all together in one neat package. So
yeah, the Big Green Bus is a great story. It was indeed, and the students have confirmed this for me, that their interest in getting to an ultimate Frisbee tournament on the West Coast with very little money as they were about to graduate that led to the development of what's now a campus-wide effort. They purchased an old school bus, converted it to run on waste vegetable oil, on biofuel, and drove it across the country to get to their Frisbee tournament. Most, but not all, of the students that first year were engineering students. Well, this has now become a regular part of the Dartmouth landscape. There is a bus that's outfitted not only to run on biofuel, but with solar panels on the roof to power laptops. It's a group of dedicated students who travel the country each summer speaking to school groups and at community fairs about the development of alternative fuels, the challenges in doing that in an economically effective way, and also connecting their engineering and science and liberal arts educations directly to tackling some of these big problems. It's a really exciting project, and it's just one example, I think, of the creativity that's come out of students who have a passion. Formula hybrid racing is another example here. A group of students who work on engineering projects for the developing world is another example where students took a passion and turned it into what's now a formalized extracurricular activity.
Is that the Help?
That's the Helble group. That's right.
Yeah, neat. One of the things that I always find really fascinating is it called Engines 20? Is that the introductory sort of design or project?
21.
21, Engines 21.
Right.
And just listening to what students do in that class. And I think it'd be interesting also because there was a question earlier on about working in teams, working collaboratively. So what is the Thayer School known for? And just wondering if you could talk about because I do think Dartmouth students have a very strong collaborative and cooperative spirit, and so a class like Engines 21, where you bring groups of students together who probably don't know each other, right? And they come together to solve a problem, a real world problem.
They don't know one another, and they have very little engineering expertise or training at this point. So Engines 21 has a pretty prosaic title. It's called Introduction to Engineering, and it's actually the first required engineering course in the major. In Engines 21, students come together and they are given a theme for the course by the instructor. This year it was products and processes to improve the quality of life. And this was actually building off of the themes that President Kim had mentioned in his inaugural address the day before the term started. Themes have ranged from healthcare to children's projects to safety to efficiency. It's a broad theme every year. Students are broken into teams, and they are asked to conceive of and identify a real opportunity, a real need in society in this broad area that they think can be met with a new product or process. They brainstorm, they design a prototype, brainstorm some more, finalize the prototype, design the prototype, build the prototype, test the prototype, do an economic analysis, do a patent analysis. Every step of the way in teams presenting to a review board. So you're not sitting in a classroom being lectured to by a professor. There's some lecture, but it's really hands-on creativity. And what these students do at the end of a 10-week term is absolutely incredible. And some of them wind up patenting and pursuing and sometimes even turning into a business when they graduate that idea from their Engines 21 class.
Yeah, that's what I think is so neat. And also when you said 10 weeks, I realized that's a lot to do in a 10-week period. And I know if you're at Thayer School sort of late at night, this place seems to be alive with students 24/7, right, working on projects and groups. And it seems like it's a place where students like to congregate as well when they have free time. They're hanging out down here at Thayer.
Right. We should stress that, Maria. They are having fun
while
they're doing this.
They're having fun.
Right. They're having a great time. And one of the things that I find just really impressive every year is how both articulate the students are and how passionate they are in describing what it is they're working on, the problem they're trying to solve, and how it fits in the broader context. And you can really see that marriage of technology and the liberal arts environment and background just in talking to these students about their work.
Neat. I'm going to try to knit together a couple of themes that are emerging from the chat as well, and some of the things that you began to talk about, Joe, particularly around HELP, the sort of Humanitarian Engineering group, and there's a question here from a student who's wondering what kinds of outreach and community service programs are Thayer students actively involved in. And I know some of those are more local and some are more global, but it'd be great to just talk a little bit about how students take their engineering and really give back to the community and do outreach and sort of how that works here at Thayer.
Right. There really is a mix between the local and the global. I'll start with the global because we mentioned HELP. This is a group of students who 4 or 5 years ago had an idea. And they call themselves Humanitarian Engineering Leadership Projects, or HELP worldwide. And they identify a couple of communities, typically in the developing world, where they focus on meeting different infrastructural needs. Teams of students design, build a project, go to these countries, implement the project, and then really work with the local community to hand off the technology and help create entrepreneurs in the local community who can replicate this in the surrounding area. And so they've worked on things ranging from new cook stoves that reduce air pollution in indoor cooking environments in sub-Saharan Africa to micro hydro turbine systems to deliver electricity for small remote villages to clean water supply systems. And so that at a global level is just an incredible activity and a broad range of projects these students pursue. Locally, it tends to be really focused on community organizations. Yeah. There's a group of a student organization here in the engineering school. They call themselves Thayer Council, and they're really the student leadership group within the engineering school, comprised of representatives from the undergraduate program all the way up to the PhD program. And they identify a couple of local community activities and days of service every year where they get the whole Thayer community or a large portion of the Thayer community involved. But here I think we're always looking for new ideas and new energy, and so if it's something that next year's freshmen have an interest in, I'd certainly be interested in hearing from them about it when they're here on campus.
Neat. As you were talking, we got another question that sort of ties into one of the themes you mentioned earlier. We talked about the big green bus and the sustainable sustainable energy sources. And so a question here, how does Thayer School work to help make Dartmouth more eco-friendly? And I know sustainability is a real theme on campus and a lot of green initiatives, and we were talking earlier about the light bulbs in your office, which our viewers can't see, but there's lots going on.
Right, even the chandelier has compact fluorescent bulbs here in my office. We thought it was important for a school that's focusing on energy as one of its particular areas of research and teaching emphasis and expertise that we walk the walk. We don't just talk about it in the classroom. The development of sustainability and broadly looking at energy opportunities is really an activity that is growing at Dartmouth. I think there'd be a lot of opportunity for new students coming in to participate. There's a sustainability house that was started by a group of students a few years ago. The faculty advisor to that group is in fact an engineering professor. Engineering faculty are involved in lots of different activities on campus that are looking at the energy footprint and the carbon footprint of the entire campus. But a lot of these efforts, I think, interestingly and impressively, are student-led right now. And so I think there's opportunity here. There's a sustainability, there's a new faculty member in Arts and Sciences who's a chair of sustainability science, and she's had several meetings here working with engineering faculty to look at curricular opportunities broadly that would address sustainability and involve the engineering school.
Right.
And so, go ahead.
Yeah, I was going to say, I remember earlier in the fall, President Kim met with a group of students to talk about their concerns about really pushing Dartmouth to be more sustainable. And he really challenged the students to come up with some plans, come up with some ideas, and I guess that some of them are probably engineering majors, but also liberal arts students more broadly, and so that's neat. It's neat to see what they come up with.
Yeah, absolutely. There have been several, here's a great opportunity taking a class like Engines 21. Over the past few years, there have been student groups in that course who have developed project ideas that could reduce energy consumption on campus. So things that could for example, help students in dormitories remember to turn their lights off more frequently and not waste electricity. And so card-activated systems that could make that happen automatically. These kinds of project ideas are things that engineering students are working on.
Speaking of Engines 21, I meant to ask earlier, is there a favorite project or something that was just so outlandish that you thought this is never going to fly, but somehow they pulled it together?
That's an unfair question. I don't have a favorite project, and there are interesting projects every year. I think one of the projects is perhaps best known and a great story is the gyro bike. And I'm sure you know the story, but here is a group of students who 5 years ago had an idea for a different way to stabilize children's bicycles, a way that's different from training wheels, that more accurately mimics the motion that a bicycle undergoes when a child's learning to ride it. Long story short, when they proposed the idea, the review board and some of the faculty said they weren't convinced that it would work. And the students, to their credit, rather than stepping back and saying, we'll try something different, were challenged by that to do a deeper analysis, showed that it would work, built a successful prototype, in the end won several awards, including a national award, teamed with an alumnus or a student at the time from the business school, and while the engineering students have gone on to do different things, this is now a commercial operation that's selling product.
Yeah, I think that's really neat. That's a great example of one of the things that I think the whole campus is aware of when a project like that goes viral, if you will, right? And people learn about that. As you were talking about the project, I mean, this is all based on the Engines 21 class, but a couple students are asking if students want to take on a new project, and it sounds like it's not part of the class itself. How would you go about starting a project, getting resources, so you have an idea? Maybe it's a thesis in the, an honors thesis in the major, or just an idea that you'd like to work on. How does that work at there?
Right. The best way to do it is to sit down with a faculty member who shares your interest, even in the broadest possible way, and talk with him or her about what you'd like to accomplish. There are resources to support student project work. Many times, but not always, a project will develop from one of the classes, like Engines 21 or another project-based course. Every year we have individual and small teams of students who are pursuing their project from a class to the next level and getting independent study credit for doing that. As I said earlier, there are lots of research projects that individual students pursue by connecting with a faculty member in a particular area of expertise. Students get involved in doing senior honors thesis, and that too comes out of an interest that they've expressed to a faculty member. And so it's very easy to make that connection. Recently we had students, one in particular I'm thinking of, who was interested in a particular problem related to a pediatric cleft palate surgery, and very quickly she was connected with a surgeon at the hospital, was observing surgery in the operating room, took that knowledge, turned it into a nice senior honors project. So opportunities are wide open. All you have to do is ask.
And are students required to do a project in their major? Is there a sort of capstone requirement for the engineering major? I know we generally have culminating experience requirement for students in all majors. I'm just wondering what it's like in Thayer.
Right. There's a culminating experience requirement like any other major, and there's a list of ways that the details are actually in our catalog and curriculum where an AB student, a Bachelor of Arts student, can meet it. Most of our students also get the BE degree, the Bachelor of Engineering degree, and there is a structured 2-term capstone design experience. And these tend to be projects that are provided by and sponsored by an outside entity, sometimes a nonprofit, sometimes a physician at the hospital, sometimes industry, and the students in teams are working with that individual much as they would if they were engineers in a client-sponsor relationship in industry. And so it's a great capstone experience that pulls together all of their underlying knowledge in an open-ended, non-disciplinary project. And even some of those students wind up developing improvements that are patentable and that become the basis for their careers.
Right, neat. Let's segue to a couple of admissions questions, and then we'll come back to some engineering-specific questions. We had a question earlier from a student who was wondering, he had done some research, and does the admissions office want to see the abstracts of the research, or does the Thayer School of Engineering want to see the abstracts of the research projects? And I think, again, because we have a holistic review process, we're not admitting you to a specific program or major, it probably makes the most sense to go ahead and send that directly to the admissions office. Obviously, we probably don't have the expertise to analyze it in depth, but certainly a very simple abstract that describes the project that you were involved in, who sponsored it, was it for school, was it an out-of-school, a summer experience, any of that information is really helpful for us to know. It helps us understand what your academic interests are, why perhaps engineering is a real passion for you, and what you hope to do with that. So that's really great information that you can share directly with the admissions office. If it gets its way to Thayer, I'm sure Joe will take a look at it, but probably send it right back to us to include with the applicant's information.
But we'd love to, if you do apply and are admitted and matriculate once you're here, we'd love to hear about it.
Yeah, exactly. And another question from Katie, who's asking, she's planning on coming up for a visit. Is there someone she can get in touch with about sitting in on a class at the Thayer School? And first up, Katie, would be the admissions office. We have a schedule every term of the classes that are being offered, and so we'll definitely let you know what classes are being offered in the engineering department and the times of those classes. The Thayer School also sponsors a tour weekdays at 1 o'clock, and so we would definitely point you in the direction of coming down to Thayer. And if you give us some advance notice, I'm sure we'll be in touch with Joe and let him know, and can definitely hook you up with a professor or a student at Thayer to talk more about being an engineer and answer any specific questions that you have about studying engineering at Dartmouth.
Right, and we do, as you mentioned, Maria, we do have information sessions that the engineering school runs in conjunction with visits to the admissions office. Students can find their way down here and participate in an information session and a tour. And those information sessions, the vast majority of the time, well over 90 or 95% of the time, are conducted by a member of the engineering school faculty.
Right.
And so here's an opportunity immediately to sit down in just a group of 5 or 6 with an engineering professor and ask all sorts of questions about the curriculum and research
Right.
opportunities and integration with the liberal arts curriculum.
Right, and that's probably a great time as well for the student who said, I've heard that engineering is the most time-consuming course of study. Do engineering students at Dartmouth have time to participate in other aspects of campus life? So I think about coming to Dartmouth, visiting, talking to a current faculty member, talking to current students, should give you a really good sense of the breadth of activities that engineering students are involved in. Extracurricularly, we talked earlier about the Dartmouth plan and how engineering students can take advantage of off-campus study, whether it's engineering or another discipline. So the answer is yes, engineering students can participate in all aspects of campus life. Might take a little more planning and organization, but
Right. Engineering
doable.
students really are broadly involved. There are engineering students who play in the symphony orchestra. There was an engineering student who for several years oversaw the construction of the snow and ice sculpture
That's
during
right.
Winter Carnival.
That's right.
There are many, many engineering students who participate on our intercollegiate sports teams. In fact, a year ago, the captains of the men's and women's ski team were both engineering students. So engineers and engineering students can participate in the full range of extracurricular activity at Dartmouth, the same as you can in any other major.
And I think it's fair to say they choose Dartmouth because they want that breadth of experience both in and out of the classroom. They don't want a very narrow educational experience. They want the breadth of liberal arts that we talked about earlier, but also the extracurricular and co-curricular life that really round out the educational experience.
Yeah, I think walking, if you were to walk across the middle of the campus and see a mixture of engineering students and non-engineering students, you couldn't differentiate them based on where they were heading, what activities they were participating in. They really are involved in the full range of activities here at Dartmouth.
I think what I'd like to do, we have a little bit of time left, is tackle some of the questions that basically ask about after Dartmouth. So do many biomedical engineering graduates go on to get accepted at medical school? Do more graduates go to graduate school or into industry? So maybe we talk a little bit about what happens after Dartmouth. You've done your BA,
Right.
maybe your BE, and now what's next?
It's about a 1/3, 2/3 split, at least that's what we've seen over the past several years. So about 1/3 of our graduates go on for further graduate study immediately, and 2/3 will go off and work in a nonprofit, but sometimes in the business world, but largely in industry. And they really pursue the full range of professions: large company, small company, entrepreneurs starting their own company. Those who go on for further study, there seem to be a few every year who do go on and study medicine, biomedical engineering graduates in particular.
Yeah.
The curriculum is in fact structured to help students prepare for entrance to medical school if that's what they're interested in. There's in fact a biomedical engineering track, biomedical engineering sciences track set up specifically for that, and there are lots of research opportunities, some of which we mentioned earlier, that give students that kind of extra component in their undergraduate experience. So they go to medical school, occasionally they go to law school, often they go to graduate school, and most frequently they do leave and find very challenging jobs immediately after graduation.
Right. And I think you touched on this very briefly in an answer to an earlier question, but I think it ties into the biomedical engineering. And to make sure that students know, Dartmouth has, at the Dartmouth Hitchcock Medical Center and the Dartmouth Medical School, two of the most important medical institutions in northern New England. And because of our the small nature of our community, undergraduates have incredible resources and opportunities to work with medical school faculty, to work with doctors at the hospital in their undergraduate careers. Maybe you want to touch a little bit about, again, on what students do with those resources.
Yeah, that's absolutely true. We have medical school faculty who co-teach some classes even at the freshman level with engineering faculty. There are design projects, as I said earlier, that are sponsored by or involve as technical subject matter experts, members of the medical school faculty or physicians from the hospital. About 40%, actually it's slightly more than 40% of the engineering school faculty right now are doing something collaboratively with a physician, either at Dartmouth Medical School or at Dartmouth Hitchcock Medical Center, the hospital complex right here in town. And so there's tremendous opportunity. It's a very interconnected network, and here too I would say, how do you make it happen? Find a member of the engineering faculty who's working broadly in the biomedical area and ask.
Yeah.
It's that easy.
Yeah, which is really great. And I think for those of you who may have tuned in, we had an earlier chat this month about being a pre-health student at Dartmouth. And at that chat, we had a lot of questions about studying engineering and also following a pre-med track. And lots of students are doing that. And I think a lot of students in that chat were really wondering sort of what Dartmouth's success rate is. And I think we have a terrific track record in terms of preparing students to go on into whatever field they want. So being an engineering major at Dartmouth means really the world is open to you when you graduate in terms of careers and possibilities. And what are some of the most interesting things that Thayer graduates are doing that maybe you don't think are as literal a jump as you might think from an engineering major to doing engineering work as a graduate?
Wow, that's a really good question. What are unusual things that engineering graduates are doing? Well, I can think of one alumnus in particular from, this is some time ago now, the 1950s, but I discovered only recently that he was in fact a member of U.S. Congress who was representing the district in central Pennsylvania where 3 Mile Island resides at the time of the nuclear incident. Now that's going on 35, almost 40 years ago, so that's some time ago. Well, okay, not quite that long, 30 years ago, but there was someone who took his engineering training in a very unusual direction. There's a senior member of the Department of Energy staff who is an engineering graduate. There are many venture capitalists who are in fact engineering graduates, and so they're not practicing technology, they're investing in technology. Now, as I'm answering this, I'm scratching my head trying to think about whether there are any stage or screen stars,
That's
something really
wondering.
unusual who's an engineering graduate,
arts
and
who's
if
an
you're
engineering
out there, I'd like to hear from you.
Yeah.
I can't think of any offhand, but there are students, architects, designers of renewable structures, people working in very traditional ways in large corporations, people working as corporate CEOs, people doing a whole range of things in the technology and business and government sectors, and many, many alumni who have become physicians, as I said, several every year.
Right. Okay, well, I think we've come to the end of our chat, and so I really, Joe, want to thank you for participating. It's been a lot of fun, and I hope those of you who've tuned in have gotten a really great sort of insight in what it means to study engineering at Dartmouth. I know that both Joe and I, as well as our colleagues in admissions and at the Thayer School, would be really happy to answer any questions. One of my colleagues, Ben, who's been helping manage the chat, has been posting some neat links for you to check out, and I think at the end of this we'll also put some information on the admissions blog, and Thayer has actually a fabulous website. I think you guys really are leading the campus here in terms of all the information on the Thayer School website, so I hope if you haven't already, you'll have a chance to check out the Thayer School website. You've got a great set of tools for students to use to get to know the classroom, get to know the faculty, get to know a little bit about the facility and the programs, and so I hope folks will check that out.
Well, thanks, Maria. It's been a pleasure doing this with you. And just one
site
I'd point you to in particular, if Ben
Absolutely.
hasn't done that in the links, is among the various bits of information available on our website. I would particularly encourage anyone who's interested in learning more to go to our panoramic 360-degree tour. It's called Thayer 360, and to explore some of the different rooms, particularly the Couch Project Lab and the Great Hall, and click on some of the videos, and that will really give you a sense of the strong sense of camaraderie and community that exists among the engineering students as they're working on these very intense and creative design projects. Thanks for allowing us to participate. It's been a pleasure.
Great, and so good luck to everyone on your admissions applications.
Thank you.
All right.
Okay.
Thanks, Ben.